exposition about the field, just to get excited, and then this is the paper that I alluded to before with iCard that formalized the PCH. Now, what is the PCH? The PCH have these different levels. I go fast here, given Francesca already did some of the lifting yesterday. But you have the first layer that is the associational, symbolically very, very specific type of symbols that we use, like P of Y given X. Very related to the scene, as I mentioned. How would seeing a variable X, and I will be very relaxed here in the notations, don't get too nervous, some people get, but how would seeing X, random variable X equal to little x, instantiation, change my belief in Y? You spend maybe a few hundred years trying to work in this particular type of query, very related to the machine learning, supervised and unsupervised learning. Is an instantiation of this, can be interpreted as a function of being able to compute that. Through time, through our history, you have different formalisms that were used to perform inference related to that. For example, in the 80s or 90s, when it started, we have base nets. At some point, we have decision trees. All the time, we have support vector machines. Maybe 15 years ago or so, more prominently, we have deep neural nets. But in reality, we can kind of dance around, but we are trying to evaluate an expression like that. And why common question that I get is why did it take so much time, or what are we doing? Very, very hard. You can go, I don't know, 300 years, 400 years, you can write that. But it's very hard to evaluate that at scale, right? To have this X here that is a 1 billion dimension variable, and the Y is also a complex object. Then how to do that at scale? This is a huge achievement that kind of unlocked many of the things that we are seeing now here, including having temporal data or some kind of sequential model as the current language models that we have. Very cool, amazing. Now, but this is not the whole picture. I also have the second layer that is the one related to the muscles or related to the interventions. Symbolically, you already can see a difference that we have the P of Y given to X. If you do the action X, how the outcome Y will be in context, for example, C. What if I do X? Also, there are different ways in machine learning to do that, or the window of machine learning to this type of capability, you can get like a reinforcement learning. Just got that Sutton and Bartol, just got the Turing, and for, I don't know, maybe 40 years working in how to make this real in some way, or using the reinforcement in an online and offline way to make decisions. This is our way, machine learning AI way of making decisions. There are also different formalisms that can implement inferences and the different variations that we have for this problem. One is a causal-based net or interventional-based net, layer 2, and the other is like a MDP, a classic by Bellman, or the POMDP, the partial observable MDP, and so on, Markov decision process. I'll defer, but there's a whole world here to be explored. Here, important for us in our context that we're trying to realize Turing's and Yuda's type of picture is about these layers, very limited way of interacting with the world through interventions. There's much more, but still it is the window of getting some type of interventional data in the world. We like to enlarge that. We understand the limitations first. Any discipline, once you go towards a science of AI, it means that you will understand what are the limitations of the technology and the trade-offs involved. This is what it means to do the science. There's no magic. Once you just understand where we are in the landscape. And then you have the third layer that people like, and that is the counterfactual way. You also have symbolically important here for the computer scientists in the room that we have queries like that there is no do. You have something after the conditioning bar. Maybe Joe took the drug that is X prime, big X is equal to little x prime, and he's dead, gone, that is Y prime. And now through counterfactual here, you can ask, you could wonder, would he be alive, that is the Y, that is the opposite of Y prime, had he not taken the drug, that is the X, that is the opposite of X prime? This is not layer 2 quantity, we are not masking. People are confused about what are the counterfactuals. Sometimes they say this is counterfactual. In some way, it's very simple. but this is a real one. There is no way that you can go back in time, bring Joe from the other side, submit him to the other condition, and see how things will unfold in time. There's like a metaphysics here, way of doing. Humans do all the time when we're using our imagination, retrospection, introspection. Key to answer why type of queries, why something happened, and what if I had acted differently. Try not to eat much, but I ate a cookie. Would my weight be different in some way? It's already gone. I didn't put inside. It was in the hotel, it was nice, and so on. Mundane example, many implications to the health. But humans use all the time in terms of blame and responsibility and basic understanding, or fundamental understanding of system. That's the hierarchy. The formalization of the PCH provides a way to measure the capabilities, I would like to think, or expressiveness of different formalisms with respect to increasingly complex query. As a result, called the hierarchy theorem that I will recommend. I'll defer for now. But the idea, at least the basic one, is about someone shows completely different formalisms for you because things look like very different. Can you kind of standardize in terms of the PCH in order to compare things and understand, is the system able to do this type of reasoning? Is the system able to do this type of reasoning, and so on? Is a way of trying to understand the capabilities of the system, despite what people are selling or saying in some way, in a more formal way. Now, what's the challenge here, or why am I saying that? I'm going to say this kind of moves us beyond the most traditional. We are doing all kinds of stuff nowadays. The most traditional type of ML. I removed layer 3 just to remove the clutter a little bit, but kind of core 101 causality, my CI1 causal 1 class, I teach 2. This is kind of the first 2 weeks. Why are we here? We are here because most of the data that we have is coming from one layer. Staple, inference, and causality, cross-layer inference. Data is coming in from layer 1, for example, EB numbers. 99% of the data in the world is from layer 1, passively collected. And many of the inferences in the world are about layer 2 or layer 3. Then you have some kind of tension here, because how on earth can you make an inference about the distribution? There's a probability distribution P and a probability distribution P prime here. Then how can I make an inference about P prime collecting 0 data points if my data, given that my data is coming from P? In principle, impossible, because those are 2 different distributions. Now, in practice, what binds these layers and what allows us possibly to do inference is that they are generated by the same model. And you start learning and imposing some assumption about the model class. Causal graph is one example, there are others, and then we start possibly able to link, to bridge these different distributions. Inference is just doing that, and a lot of dance there. Sometimes we spend 10 years trying to see how we can bind these distributions in a way, in a principal way and systematic. Right now, picture here, then we'll talk about putting the perspective of generative AI. You have this unobserved reality, and there is an underlying causal model there that in 99% of the case you will not observe, but very specific situations, maybe in physics, maybe in chemistry, maybe economists believe that sometimes they can get it, but almost never possible. And then this causal model generates a PCH. PCH, collection of distributions that we discussed. There is one observation distribution by agent. There is many intervention distributions, depending on what are you doing intervention on. And there are many counterfactual, many versions of the world that still don't exist that you can entertain. Now, beautiful picture. Now, in general, this part is occluded. You don't observe, because most of the data is coming from the RAP. Now, what are you trying to do? What is the dance here? You have a neural model, let's call N hat. Can be whatever complexity you want, can throw complexity there. And then this is kind of empty, has the potential answering the queries, but in principle, it's kind of underdetermined or silent in reality, I think is a better word. Now has the potential for the different distributions, L1, L2, L3 distribution. Now what do? We spend time, maybe in the cluster, and then we kind of train the system, maybe take a week, maybe take a month, and then we are able to, maybe 6 months, depending nowadays, and then we are able to replicate the red. Beautiful. Now, but what does this tell us about the obfuscated or the non-observed yellow? And I call this fundamental problem of Gen AI. That is a question, methodological here, fundamental, under what conditions inference on n and hat in the right side are valid. In other words, when do they recover the distributions induced by the left side?